Understanding, Permutation and Combination, Part 1. First we go through the fundamental rules of counting, that is understanding, and/or cases. Second, we cover permutation, that is finding out all possible arrangement. At last we cover combination, that is finding out all possible combination. Fundamental rules of counting, let's understand by an simple example. Question is, in how many ways you can select one ball out of these 5 balls? You can select first ball B1. Or, you can select second ball B2. Or you can select green ball G1. Or you can select ball B3. Or you can select last one G2. So you can select either B1, or B2, or G1, or B3, or G2. That is, you have 5 options to select. Or we can say, total 5 ways. Now change it to different situation. In how many ways, you can select one blue ball, and one green ball, out of these 5 balls. Let we pick ball B1. With B1, either G1 is picked, or G2 is picked. Similarly, if we pick B2, either G1 is picked, or G2 is picked. Similarly, if we pick B3, either pick G1, or pick G2. So, there are total 6 cases, in which one blue ball, and one green ball, is picked. Or, we can say, we can select blue balls in 3 ways, and green balls in 2 ways. So, total number of ways of selecting one blue ball and one green ball is 3 into 2, that is 6 ways. Let's do an example. Between 2 station A and B, a train can run in both direction and have 4 different routes. How many different ways train can have between stations if it to go from station A to B and return from B to A? Case 1. It can take any route. Case 2. It must take the same route. Case 3. It cannot take the same route. We represent this situation in this diagram. In case 1, if the train can take any route between A and B, it has 4 routes, each to and fro. So, 4 into 4 equals 16 total routes are there. In case 2, 4 routes are there, from A to B, and from B to A, only one route, which the train has taken from A to B, so we have 4 into 1, equals 1. Total number of routes. In case 3, as train cannot takes the same route, while returning, so to return to A, from B, the train cannot take one route, that is the route it takes from A to B. So 4 routes are there to go, from A to B, and 3 routes are there to return. So total is 4 into 3, that is 12 routes. Now we come to permutation, that is number of ways to arrange. Let's start with example. In how many ways, these 5 number balls can be arranged to form different sequence each time? These are the 5 places to form sequence. In first place, either ball with number 1 can be placed, or with ball with number 2 be placed, or ball with number 3 be placed, or ball with number 4 be placed, or ball with number 5 be placed. It means, place 1 can have 5 option, any ball, 1, 2, 3, 4, 5, can be placed. So, first place has 5 option, any ball out of 5 can be placed here. Place 2 can have 5-1 option, as one ball, out of these 1, 2, 3, 4, 5, is already placed in place 1, so left with 4 balls, options. So any ball out of remaining 4 can be placed here. Place 3 can have 5-2 option, as 2 ball, out of these 1, 2, 3, 4, 5, are already placed in place 1 and place 2, respectively, so left with 3 balls options. So any ball out of remaining 3 can be placed here. Place 4 can have 5-3 option, as 3 ball out of these 1, 2, 3, 4, 5, are already placed in places 1, 2 and 3 respectively, so left with 2 balls options. So any ball out of remaining 2 can be placed here. Place 5 can have 5-4 option, as 4 balls out of these 1, 2, 3, 4, 5, are already placed in places 1, 2, 3 and 4 respectively, so left with 1 balls option. So only 1 ball is left, that can be placed here. So, total options in which all these combined balls can be arranged is 5 into 4 into 3 into 2 into 1. That is 120 ways. Or we can say, there are total 5 balls. And out of these 5 balls, we have to arrange 5 balls, without repetition, means balls once placed, cannot be taken, in next time, it is represented as 5, p, 5 that is 5 factorial divided by 5 minus 5 factorial. Whereas in 5, p, 5, blue 5, is the total number of balls. And green 5 is the number of balls to be arranged. What if we want to arrange only 3 balls out of these 5 balls, then how many possible number of ways we can arrange with no ball is repeated? Explanation: as there are now only 3 balls to be placed in 3 places, first place has option of 5 balls, and second place has option of 4 balls, and last place has option of 3 balls. So, total number of ways these balls can be arranged is 5 into 4 into 3, that gives total 60 ways. Or simply, we can use permutation. That is, out of 5 balls, we need to arrange 3 balls. 5, p3, that is equal to 5 factorial divided by 5 minus 3 factorial. Hence equals to 60 ways. Let's solve some example. In how many ways can an animal trainer arrange 5 lions and 4 tigers in a row, so that no 2 lions are together? 5 lions plus 4 tigers means 9 animals are needed to arrange, as no 2 lions come together. So places 1, 3, 5, 7, and 9 are places of lions, and place 2, 4, 6, 8 are places of tigers. We have shown places of lions and places of tigers in this diagram. As place 1, 3, 5, 7, and 9 are places of lions. In these places, lions themselves can be arranged in 5 factorial, or we can say 5, p5. Similarly, tigers in places 2, 4, 6, 8 can themselves be arranged in 4 factorial, or by permutation we say 4, p, 4. So, 5 lions and 4 tigers can be arranged in 5 factorial into 4 factorial, or we can say 5, p, 5, into 4, p, 4. One more example. In how many ways can 4 tigers and 5 lions be arranged in a row, so that all the 4 tigers are together? As all tigers always need to be together, make all tigers group as one unit. These unit can be arranged in 6 into 5 into 4 into 3 into 2 into 1, that is 6 factorial, or we can say, 6p6, means there are total 6 units, and we have to arrange 6 of them. These tigers, grouped as one unit, are themselves be arranged in 4 into 3 into 2 into 1, that is 4 factorial, or 4p4, ways. So, total number of arrangements, equals to, total number of arranging units, into, total number of ways arranging tigers, that is, 6 factorial into 4 factorial, or, 6p6 into, 4p4, which gives total, 17,280 arrangement.